A Harvard scientist just broke the silence, and the numbers aren't polite. 3I Atlas, the newest interstellar visitor blazing through our solar system at 130,000 miles per hour, is shedding metallic alloys that don't make sense by any playbook we've used on comets, asteroids, or interstellar rubble. Real telescope data shows atomized nickel lines in its wake, with almost zero iron. Read that again. In space chemistry, nickel and iron are twins, born together in dying stars, fused into the same minerals, and released together when sunlight cooks a comet's skin. So, why is 3I Atlas flashing nickel like a beacon while iron is basically ghosting the spectrum? That's the question Harvard's Avi Loeb is throwing down like a gauntlet. Even if you think his past takes on Oumuamua went too far, you can't ignore the fingerprint here. Strong nickel, missing iron. On Earth, separating those metals is an industrial task. In nature, they're a package deal. If this ratio is real and persistent, we're either staring at an extreme cosmic forge no one's modeled correctly, or something engineered to stand out. Let's rewind to the discovery, because the origin story already screams not local. On July 1st, 2025, Chile's Atlas survey tags a faint speck ripping across the sky. Backchecks pull it from June 14th data. A one-and-done flyby from deep space that the sun will never reclaim. By the time most people even heard the name, 3I Atlas was already inside Jupiter's orbit, sprinting toward a single slingshot around the sun, before diving back into the dark. Speed? 58 km per second relative to the sun. Size? Staggering. This isn't a snowball, it's a messenger from another star. Only the third confirmed interstellar object humans have ever seen. That alone would be historic. But then the spectrum lit up. Nickel lines appear as it warms. The Very Large Telescope in Chile measures 4.6 grams per second of nickel streaming off the coma by late August. That's a healthy, confident signal. Iron, though? Nothing. Not a hint to balance the books. In every meteorite collection, in every comet we've analyzed, nickel and iron are partners. Break one, you find the other. Here, the partner's missing. It's like discovering a gold ring with no copper, no silver impurities, materials science without the messiness of nature. At this point, the story forks into two roads, both wild. Nature at full throttle. Maybe there's a natural pathway, rare, violent, but real, where nickel gets liberated and iron stays locked. Think kilonova debris from neutron star mergers, or asymmetric supernovae that fling metals into space in lopsided jets. In those cataclysms, extreme conditions can sculpt elemental pockets with bizarre ratios. If 3I Atlas condensed from one of those pockets, its nickel-only signature could be a relic of cosmic violence, not craft. It's the universe saying, "You still haven't seen my final form." The engineered hypothesis. If you were building a durable interstellar shell, nickel is a compelling choice. Hard, corrosion-resistant, stable across wild temperatures. You'd choose a chemistry that nature almost never prints. Nickel without iron is exactly that. It's a flag you can read from light years away, if you know what to look for. It gets stranger. 3I Atlas isn't just chemically weird. Its trajectory looks like it studied our solar system before applying. A route that brushes Jupiter, Mars, then Venus. A grand tour of the most interrogated worlds, before vanishing behind the sun right when it's hottest, brightest, and hardest to watch. Meanwhile, the James Webb Space Telescope pours gasoline on the fire, an 8-to-1 CO2 to water ratio in the coma, off the charts compared to typical comets. CO2 isn't rare, but dominating the volatiles like this? That's new territory. Cosmic ray cooking over billions of years could, in theory, hard bake an outer shell and skew the chemistry. Or it could be a signature of formation in a star system not like ours, a chemical passport stamped in a different neighborhood of the galaxy. So, where does that leave us? With a visitor that breaks the rules, on speed, on path, on chemistry. With nickel shouting and iron silent. With CO2 drowning out water like we've never seen. With a Harvard scientist saying the quiet part out loud, this fingerprint doesn't match anything we know. Here's the uncomfortable truth. Either 3I Atlas is the best argument yet, that nature can forge metals and volatiles in completely uncharted ways, or it's a designed artifact, camouflaged as a comet, flashing a spectral code in plain sight. Both possibilities are seismic. One rewrites astrophysics, the other rewrites us. What do you think? Nature's most extreme chemistry, or a manufactured signature drifting through our backyard? Drop your theory below and buckle up. We'll dissect the leading natural forge explanations versus engineered scenarios, and why the next few weeks of data could tip the scales hard in one direction. When word broke that 3I Atlas was spewing nickel with almost no iron, mainstream scientists scrambled for explanations. The safe bet is always nature did it, and maybe it did. But when the evidence stacks this strangely, the natural explanations sound almost as wild as the engineered ones. Let's start with the cosmic forge theory. Some astrophysicists point to neutron star mergers, kilonova, explosions so violent they forge metals in bizarre ratios. In 2017, astronomers caught one in action, JWST 817. They didn't just see light, they watched new elements being born in real time. The blast scattered exotic isotopes like strontium and nickel across space. Models show that in some patches of debris, nickel can dominate while iron gets trapped in dense knots. If 3I Atlas was born in one of these stellar foundries, its weird chemistry could be a fossil of that chaos. A fragment from a star's death throes, wandering for billions of years until it blazed into our solar system. Another natural candidate is the asymmetric supernova. Normally, a supernova blasts out elements in neat layers, but some go off-center, ejecting jets of certain metals in one direction. NASA's Chandra telescope has mapped remnants where nickel was flung out like confetti, while iron stayed closer to the collapsed core. If 3I Atlas condensed from one of those nickel-rich plumes, it might explain why our telescopes see nickel but no iron. These are compelling theories. But here's the catch. They're rare. Astronomers study hundreds of supernova remnants, and while asymmetry is real, the odds of catching one specific fragment that formed almost pure nickel, survived billions of years, and just happened to swing through our solar system, vanishingly small. You can wave your hands and say, rare things happen, but the statistical fingerprint nags at you. And that's exactly where Avi Loeb digs in. He's not saying, it must be aliens. He's saying, the data doesn't add up to random chance. He points out that nickel without iron looks manufactured. On Earth, metallurgists spend enormous energy separating the two. In nature, you can't do that cleanly, except maybe in extreme, short-lived explosions. Yet here's an object calmly coasting through our system, flashing that spectral signature like a neon sign. Now, flip the lens to the engineered hypothesis. What if the nickel signature is deliberate? Nickel is tough, resistant to corrosion, stable across cosmic extremes. If you were building an interstellar shell, a time capsule, or even a disguised probe, you might choose nickel alloys as your armor. And if you wanted curious civilizations to notice, you'd make sure the alloy ratio stood out against the universal backdrop of iron-rich rocks. The absence of iron becomes the signal. The message is, this is not random. Some theorists have gone further, suggesting isotopic encoding. In other words, the ratios of nickel isotopes themselves could carry information, like an atomic QR code. That sounds like science fiction, until you remember humans already manipulate isotopes for medicine, energy, even quantum computing. If we can do it, why couldn't a civilization a billion years older? Here's where the trajectory adds fuel to the fire. Remember, 3I Atlas isn't bumbling through space. It's threading a path past Jupiter, Mars, and Venus, three of the most scientifically interesting planets, before disappearing behind the sun in October. That blackout period is critical. From Earth, we won't be able to see it. Even our space telescopes will struggle against the glare. If you wanted to make a move unseen, or beam data without being watched, this is the cover you'd choose. Coincidence? Maybe. But combined with the nickel anomaly, it feels like more than chance. So, which side wins? The natural forge or the engineered artifact? Supporters of the natural explanation say, wait for more data. Rare doesn't mean impossible. Supporters of the engineered camp say, the odds of this happening by chance are microscopic. Stop pretending otherwise. The truth is, both possibilities are disruptive. If it's natural, then we've discovered a new class of cosmic chemistry, forged in environments we barely understand. That alone rewrites astrophysics. If it's engineered, then we're staring at evidence of intelligence beyond Earth. Either way, we're not walking away unchanged, and the suspense is building. As 3I Atlas nears its closest pass to the Sun, new readings from the James Webb Space Telescope and ground-based observatories are expected. If the nickel signal strengthens, or if subtle course shifts are detected, the arguments will intensify. Every new data point will either shore up the natural case or hammer home the possibility that something unnatural is in play. What's your take? Do you buy the natural forge theories, or does the missing iron scream engineered to you? Drop a comment because we'll go one step further, into history, myth, and the possibility that humanity has seen signs like this before. We've broken down the nickel mystery. We've walked through the natural forge explanations and the engineered alien theories. But here's the part that most people aren't ready for. This isn't the first time humanity has faced metals from the sky that don't add up. History is full of echoes, ancient artifacts, cultural myths, even past cosmic visitors that feel eerily connected to what's happening now with 3I Atlas. Thousands of years ago, long before furnaces, before iron smelting, people were already working with metal. How? They didn't mine it. They found it falling from above. In ancient Egypt, tiny iron beads hammered into ornaments have been traced to meteoritic sources. The chemical fingerprints showed high nickel content, ratios impossible to produce in primitive forges. In King Tut's tomb, archaeologists discovered a dagger whose blade wasn't just ceremonial, it was extraterrestrial. X-ray scans revealed nickel and cobalt in concentrations only found in space-borne metal. Egyptians called it iron of the sky, treating it as a divine gift reserved for pharaohs and gods. Across Mesopotamia, China, and even among early Anatolian cultures, meteoritic iron turned up in daggers, axes, jewelry. Always rare, always revered. People knew this stuff didn't belong to Earth. They didn't understand kilinovae or supernovae, but they understood that these alloys were different. Now, fast forward thousands of years, and here we are again, staring at an object shedding nickel without iron, the same kind of anomaly that would have blown the minds of ancient craftsmen. The difference is today, we have telescopes and supercomputers, and the implications are far bigger. Think back to 2017. Oumuamua burst into the news as the first recognized interstellar visitor. It looked like an asteroid until it didn't. Its acceleration didn't match any known cometary outgassing. No tail, no coma, no explanation. Loeb famously suggested it might have been a solar sail, thin, engineered, using starlight as propulsion. Critics laughed, but no natural theory has closed the case. Then came 2I/Borisov in 2019, a more typical comet, with chemistry closer to what we expect. It reassured skeptics that not every interstellar object is strange. But now, with 3I Atlas, the pendulum swings back hard into mystery. Larger, faster, stranger metals, stranger chemistry, and a trajectory that feels like it was penciled into a map. 3 visitors in less than a decade, after none in all of recorded history. That alone is unsettling. Are we just getting lucky with our new surveys, or has the galaxy decided it's time to start sending the unusual our way? Here's the most controversial theory of all. 3I Atlas isn't just an object, it's a message, not a radio signal, not a flashing light. A message written in the ratios of metals and isotopes themselves. Think about it. Humans already send matter messages. NASA's Voyager probes carry golden records, physical disks etched with the story of humanity. Why not imagine another civilization embedding their calling card in alloys and isotopic codes? Nickel without iron is loud. Carbon dioxide dominating water by 8-to-1 is louder. Combined, they scream, "Pay attention." Instead of radio bursts that fade in static, this kind of message could last billions of years, drifting star to star, until someone with the right instruments noticed. Maybe that's what's happening right now. Maybe this is their version of the golden record, only we're just smart enough, just paranoid enough, to finally decode it. The real drama is in the calendar. On October 30th, 2025, 3I Atlas will vanish behind the sun in what astronomers call solar conjunction. For days we won't see it, we won't track it. We won't know if it changes speed, splits apart, or fires off emissions invisible to us. And when it re-emerges in early November, scientists will be waiting with sharpened instruments to compare notes. If anything changes, trajectory, spectrum, emissions, it could confirm suspicions that this is no natural rock. And here's where it gets explosive. Avi Loeb has already run the math. He claims the probability of 3I Atlas hitting this exact path, threading close to Jupiter, Mars, and Venus, is about 0.005%. That's basically zero by chance. But if it's engineered, it's perfect. A deliberate survey, a cosmic flyby of the inner solar system. So, what do we do with this? If it's natural, then 3I Atlas is the most important laboratory sample in human history. A chunk of the galaxy's strangest forges, carrying chemistry Earth has never seen. It rewrites astrophysics and gives us a new window into how matter forms. If it's engineered, then we're living in the first days of confirmed contact, with a civilization older, stronger, and more deliberate than anything we've imagined. A civilization that doesn't broadcast, it leaves atomic fingerprints. Either way, the universe just dropped a question into our backyard, and it's not one we can ignore. So, here's where you come in. Do you believe 3I Atlas is a freak of nature, a fragment of a cosmic forge? Or do you believe the missing iron, the nickel fingerprint, and the improbable trajectory point to engineering? Drop your answer in the comments, because when this object emerges from behind the sun, the truth might finally hit us, and it could change everything.